This third video will wrap up the first section of Chapter 5, 5.1. It's going to deal with growth and decay. So we've done the straight mathematical concepts, and now we're going to do some applications, and we can use what we learned to solve some word problems. In our first example, we're going to break things down step by step. Then we're going to look at the big picture and kind of how to solve it all at once. So this first problem says that if we know the price of a hamburger is $4 today, and the price increases by 4% each year, how much is a burger going to cost in the future? So the first thing we need to realize from our previous math classes, hopefully, is that 4% as a decimal is 0.04. That's going to be pretty important. So if you look at our table where it says 0 years from now, that's technically today, so we can put in $4. Now we need to figure out what's the burger going to cost in a year. Well, how we would do that is take the original price of $4 and multiply that by our rate here, our rate of increase, which is 0.04. When I do that, I end up with 0.16. In money, that's obviously 16 cents. So if we add back our $4, the original price, our price at the end of a year is going to be $4.16. Now that we're at the end of year one, we want to do something similar, but our starting value is now 4.16. So the next year, we're going to take 4.16, multiply that by 0.04. On my calculator, I get 0.1664. Since we're dealing with money, I'm going to round that to 0.17. I need to add that to our price at the beginning of the year, which was $4.16. So at the end of year two, our hamburger is up to $4.33. If we take a look at one more of these, we take our 4.33, we multiply that by 0.04. And again, when I round what my calculator tells me, I get 0.17 again. We're going to add that to our 4.33, and we end up with our hamburger being $4.50. The question is, or what would make this difficult is if I asked you, well, what's the burger going to cost 25 years from now? That you can't figure out. You could do it the long way this way, but it would take you a while. So on the next slide, we'll take a look at a formula in which we can solve this for any year. So here's the formula for growth and decay. You may want to pause and make sure you have this all down. If we think about our hamburger example and filling things in, we would have A of t equals A sub 0, it says here, is your initial amount at t equals 0. So at the current time, or today, our burger was worth $4. Inside the parenthesis, you're going to put in your rate of growth or decay. Since our price was going up by $4, R is going to be positive, and we talked about the conversion to 0.04. And then T is your time. You didn't ask you for a time yet, so that'll be in general just T. In this example, I asked you what would a hamburger cost in 2027. So I'm going to copy this from our last slide. Now we have a T value that we can plug in. If we did this how we did in the table, we'd have to do 15 different calculations for this. Now we know using our formula we can say that A of 15 is $4 times 1.04 to the 15th. And if I plug that in, that'll tell us that in 2027 your hamburger will cost $7.20. This example actually involves two problems at once. You just inherited $4,000 from a relative, but under the condition that all the money has to go into a savings account for at least 3 years. You find two options for a savings account, and I'm asking you which one you'd rather put your money in, obviously with the objective to be to earn more money or earn the most interest over those 3 years, so you have more money when you take it out. So I'm going to shrink this to make it a little easier to work. So Bank A, we'll start with that one, has an interest rate of 2%. What I want to know is how much money I'll have at the end of 3 years. So if I put our formula up here for our reference, in this case we're starting with $4,000. So for Bank A, we have A sub 3 at the end of 3 years. We're starting with $4,000. And in Bank A, our interest rate is 2%. 2% as a decimal is 0.02. So we have 1 plus 0.02 in parentheses, And we know this is going to be 3 years from now. When I plug that into my calculator, I find out that I have $4,244.83 at the end of 3 years. For Bank B, things work a little bit differently. The interest rate is down to only 1.5%, but they also give you $100 when you open the account. So when we're looking for A sub 3 here, our starting amount, when we put in $4,000, they automatically give us $100. So our A sub 0 here will be $4,100. In parentheses, 1.5% is going to be 0.015. So I can write this as 1.015. And we're going to raise that to the third power because we're still talking about 3 years from now. So if I plug that into my calculator, raise it to the third, PEMDAS, you always want to do that first, and multiply by the 4,100, end up with $4,287.28. So in this case, even though the interest rate was lower, that $100 kind of put us over the edge, so you would want to invest your money in Bank B. Our last example for this video is looking at the value of a new MacBook Air, which if you buy for $999 today, this is telling you that the yearly depreciation rate, which is a number I made up, we're going to call it 16% for now. The word depreciation means the value of the computer is decreasing, right? As your computer gets older, it's going to be worth less and less. So our R here, we know it's going to be 0.16 when we convert to a decimal, but since the value is going down, we actually need to write that as negative 0.16. So the first part of my problem asks what's the MacBook Air worth in 2 years. So when I write A sub 2, I'm going to write $999 as my initial value. We need to do 1 minus 0.16 and square that. So if I take 0.84 and square it and then multiply it by our original value, after 2 years, your MacBook Air will only be worth $704.89. After 5 years, and that's the next part, we're going to follow a similar pattern. We have A of 5. Still starting at $999. We know our parentheses is still 0.84, or the 1 minus the 0.16. Our exponent becomes a 5. Obviously, this value will be a lot less. If we raise that to the fifth and multiply by 0.19, multiply by $999, sorry, our ending value after 5 years is $417.79. So again, the key here, you need to look for whether your values are increasing or decreasing. The word depreciation is your key here. Just as a side note, what you'll see in problems, if your value is increasing, you may see the word appreciation or appreciate. If a value is appreciating, that means it's going up. In this example, the depreciation was going down. There are 3 more examples here you can work on. It has increase and decrease, maybe good practice for that. I'm not going to do them with you, but I will flash up the work for this and the answers so you can check if you want to try those before coming to class or starting the next part of your packet.